Hello everybody, welcome back. This is lesson 9 in unit 11. Today we're going to go over just some practice questions dealing with electrochemical cells. So the past few days we've gone over voltaic cells, how to label them, how stuff works, and then electrolytic cells, label them, how stuff works, and how they differ from voltaic cells. So if any of that stuff sounds completely foreign to you, go back and watch those videos. But what works best for this lesson? Try going through the practice questions on your own and then come back to watch this to go over the questions with explanations. Now the explanation in the annotated version of this is posted to the website should you want to look at it. I'll also go over it here. Just a quick reminder, if you're watching this the day that you're supposed to, it looks like the electrolytic cell castle learning is due tonight. Just make sure that you are following the calendar and any other updates your teacher may give you. So let's jump right in. Question 1 says, which ionic equation represents a spontaneous reaction in a voltaic cell? So right here, voltaic cell is one of your keys. So how are you supposed to even start this? Well, first you want to look at table J. Figure out which one is higher and which one is lower, because you want to figure out which one is the anode, which one is the cathode, and then which one is reduced, which one is oxidized. So, looking at table J between zinc and copper, Zn, zinc, is higher up. So if it's higher up, that means that's the one that's going to be oxidized. Remember, oxidizing, you're losing electrons, and if you're gaining electrons, that's reduction. So with the zinc being higher, it's being oxidized, and that makes sense because it's the more active metal. And I gave the example the other day, if you're a very active child trying to hold on to everything, the more active you are, the more likely you are to lose that, whatever you're holding. So in this case, electrons. So, then going on, if it's oxidized, that means it is the anode. And we use NOx red cat for that. So that means copper is the lower one, which means it is going to be reduced, and means it's going to be the cathode. So, looking into that, we know zinc being oxidized and copper being reduced, that's that main key we need. So, if you're oxidized, again, you're losing electrons, and if you're reduced, you're gaining electrons. So if you're oxidized and you're losing electrons, the oxidation number goes up, and if you are being reduced, your oxidation number goes down because you're gaining more of those negative electrons. So if we look at this, copper, remember anything by itself is 0, so if it helps you can add those in where you see fit. So for choice A, copper goes from 0 to plus 2, and we said copper has to be reduced, so the oxidation number needs to go lower, so that can't be right. For B, copper goes from 0 to plus 2, and again we said it has to go down, so that doesn't make sense. If we look at C, copper is going from plus 2 to 0, so that's going down. That part is correct. And then we know zinc, its oxidation number has to go up, so zinc starts at 0 and then ends at plus 2. So that shows that oxidation number going up. So that's how you would have to approach this type of question. There's a lot to kind of think about it, but if you break it down step by step by step, it is very, very, very manageable. Okay. Number 2, which type of energy conversion occurs in a voltaic cell? So remember, you have to remember that voltaic cells are spontaneous. And those are the things, once that wire is connected and that circuit's complete, things just start going. So it turns the chemical energy into, this should be electrical, my bad. It turns chemical energy into electrical energy. And if you think about it, if you have your little cell, which looks like this, in the middle, you have a voltmeter. And what that does, it measures the amount of voltage going through that circuit. So it measures the electrical energy that is being produced. So voltaic cell is always chemical to electrical. Okay, number 3, in an operating voltaic cell, reduction occurs. All you need to remember is red cat and ox. And if we're talking about reduction, we're talking about this. And it happens at the cathode. Regardless of voltaic or electrolytic cells, reduction always happens at the cathode. Number 4, which statement is true for any electrochemical cell? So remember, electrochemical cell is the big overarching term. And then we have the 2 types. We have voltaic and we have electrolytic. Just be careful that electrolytic does not necessarily mean the same thing as electrochemical. So this is kind of going into the other question, and it's asking about oxidation and reduction and where that occurs. And that is where you need to remember red cat and ox. So always reduction happens at the cathode. And always the anode is where oxidation takes place. Doesn't matter electrolytic or voltaic, they both work the same way. So that means A is the only thing that makes sense. Oxidation at the anode. You can't have oxidation occur or reduction occur at 2 different things. That doesn't make sense. Number 5, in a voltaic cell, it operates ions move through the salt bridge. That's one of the kind of definition questions. And if you think about it, here's your cell, your voltmeter, your wire. But that's not a complete picture. What you have is this kind of bridge-shaped thing. That's your salt bridge, and that allows ions to transfer back and forth and kind of keeps neutral charges in both of the different cells. Okay, number 6 says, given the balanced ionic equation representing a reaction in an operating voltaic cell, the flow of electrons through the external circuit in the cell is from the what to what. So we don't really need the picture for this. What you need is, again, we need to figure out which is the anode and which is the cathode. So this is very similar to question 1. So between zinc and copper, zinc is higher up, which makes it oxidized, which makes it the anode, and copper is lower, which means it is reduced, and that is the cathode. And remember, electrons always flow anode to cathode. In a voltaic cell, electrons flow anode to cathode. So anodes are a little bit negative, cathodes are kind of positive. So the electrons are just kind of moving from the negative side to the more positive side. So if we know that copper is the cathode, zinc is the anode, we can get rid of A and D. And then we need to know it moves from anode to cathode. So that is answer choice C. Moving forward, number 7. Very similar to number 6, but a few different elements. So now we're looking at zinc and Pb, and it wants to know, how the electrons flow. So within this pair, zinc is higher up, so that is oxidized, that is the anode. And then Pb is lower, that is going to be reduced, and that is the cathode. So we know electrons flow, because we're talking about a voltaic cell, electrons flow anode to cathode. So we know it needs to flow zinc to Pb. So we can get rid of A and B. But now we have solids versus aqueous solutions of these 2 metals. The answer is going to be C, solid, because when you think about what your cell looks like, you have your electrodes, which are these. So the electrons from one electrode leave and get deposited on the other one. The liquid in the bottom just allows this to happen, but it's literally moving from the solid thing to the other solid thing. So that is why it is C. Number 8 says what happens when the switch is closed. So when the switch is closed, it has a complete circuit so things can flow as needed. So we have zinc and copper. The first thing is to figure out which is the anode, which is the cathode. And again, that is straight from table J. So zinc is higher up, so that's going to make it the anode. And that means copper is the cathode. And we always know electrons flow in a voltaic cell, anode to cathode. So this is your electron flow. At the anode, because you remember red cat and oxidized, zinc is being oxidized, and copper is being reduced. So now we have all the information we need to look at the answer choices. So whenever you see one of these, your first task should be to label all the things that I just labeled, and then look at the answer choices. So A says zinc is reduced. That is wrong because zinc is being oxidized. B says copper is oxidized. That is wrong. Now we're talking about electron flow. We know it flows anode to cathode, and we have determined that zinc was the anode. So electrons have to flow from zinc to copper. Moving on to number 9, which device requires electrical energy to produce a chemical change, and that is an electrolytic cell. So remember, the electrolytic cell is generally one cell. It has a piece of metal, and it has a battery. So that symbol is a symbol for battery. When you do circuits in physics, you will learn that. And let's make this a key. That is a key. What happens is that you need this outside electrical energy in order to rip the electrons off of this to deposit it over there. So electrolytic cells require that electrical energy in order for chemistry stuff to happen. Without the battery, nothing would happen. Number 10, it says which statement describes the redox reaction that occurs when something is electroplated. So when something is electroplated, we need to be thinking of electrolytic cells. That's when you have like a silver-plated key or a spoon or some kind of object being coated in another metal. And electrolytic cells are non-spontaneous. So we can automatically get rid of A and B. And then the difference between C and D says requires electrical current or produces electrical current. Now, going back to this slide, you need for electrolytic cells that outside energy. You need that battery. So it requires an electric current. Spontaneous and producing electric current, that doesn't make sense at all. So that can't be the answer. But if something is spontaneous and produces an electric current, that's a valid statement. But that is talking about voltaic cells. Number 11 says the diagram below shows a spoon that will be electroplated with a nickel metal. What will occur when the switch S is closed? So with this, the object is going to be the cathode. That means this is the anode. And you can also tell that by here. The battery has the two charges. And in an electrolytic cell, the anode is now positive and the cathode is negative. So we know that electrons still flow anode to cathode. So here's your little positive section, here's your little negative section. Then it's asking what will happen to the masses of both things. So if we think about it, the spoon is going, here's no nickel, it's covered. So what happens is the ions travel through and then attach themselves to the spoon. So as the spoon gets coated more and more and more with these nickel ions, that means the spoon mass is going up and then that means this electrode is decreasing in mass. So we're just talking about the spoon gains mass, so we can get rid of A and B. And then it says nickel will be reduced or oxidized. If nickel is the anode, that is going to be oxidized, and that makes it choice D. So the only thing that changes with an electrolytic cell is that it's non-spontaneous. This is why you need that battery. And electrons are pulled from the positive side to the negative side. But it always still flows anode to cathode. Oxidation still occurs at the anode. Reduction still happens at the cathode. Lastly, number 12, which energy conversion must occur in an operating electrolytic cell? This is almost a definition-based question. As of right now, we haven't talked about nuclear energy, so don't pick that. That's our last unit. We'll get there. Electrical to chemical. That is the definition of electrolytic. And then chemical to electrical, that is your voltaic cell. So those are those things that need to just eventually sink their way into your head. But that is it. So that's it for these questions. Remember, there should be a CASEL learning due tonight if you're watching this the day of. Tomorrow is, you guys are working on the when metals eat each other case study. There is no video for that, so just make sure that you're following the directions that your teacher posted on Google Classroom for that. Read it. There are some questions. It should be submitted through Google Classroom. This is now the third case study you've worked on, so this should not be brand new news as to how to submit it. Just again, there is no lesson video for tomorrow, and then that's it. So this should be Thursday that you're watching this, so if I'm not going to see you tomorrow, have a wonderful weekend.